All right, so today we're going to be talking about the order of operations and with integers and absolute value. Order of operations is also known as PEMDAS, or please excuse my dear Aunt Sally. All right, well, first we need to know about exponents and exponential notation. So exponential notation shows repeated multiplication. So in other words, 3 to the 4th power means the same thing as 3 times 3 times 3 times 3. 3 is the base, 4 is the exponent. Okay, so if the exponent is 2, that could be read as squared. So that could be read as 7 squared. That could be, so 2 to the 3rd power could be read as 2 cubed. All right. So evaluate means to find the value. So 2 to the 3rd power means 2 times 2 times 2, which is equal to 8. So if it says evaluate, they want you to actually multiply it out like that. All right. So for the order of operations, we multiply and divide from left to right before we add and subtract. All right. So, yeah, here it goes. Exponents follow the rules for multiplication. Grouping symbols may cause the order to change. So grouping symbols could include parentheses, brackets, braces, fractions, symbols. Could also be absolute value is another possible grouping symbol. And we even saw some examples of that yesterday, I believe. One of those days, maybe. All right. So order of operations, first you do whatever is inside the parentheses, then exponents, then multiply and divide from left to right, and add and subtract from left to right. All right, so there's PEMDAS. Please excuse my dear Aunt Sally. So the multiplication and division is like one thing, and the addition and the subtraction is one thing. So that means that, so with PEMDAS, a lot of people mistakenly believe that you have to multiply before you divide. And I think that's been a source of many, many online, Facebook debates. People put these little math problems on Facebook, and then people argue about what the right answer is. And the problem is a lot of people are thinking PEMDAS means you have to multiply before you divide, but that's not true. You can divide before you multiply, you just do them in order from left to right. All right, so, but you just have to do all the multiplying and or dividing before you can do any of the adding and or subtracting. All right. So, okay. All right. All right. Use order of operations to simplify the expression. All right. So first thing we want to do is what's on the inside of the parentheses, which is 6 minus 17. So 6 minus 17 equals negative 11. And since it's negative, I'm going to keep it in parentheses for the moment. And then I'm just going to bring everything else down. So it's 4 times the absolute value of 9 minus negative 11. So whenever we see minus a negative, we automatically want to change that to a plus. So it's really the same thing as 9 plus 11. So 9 plus 11 equals 20. So it's 4 times the absolute value of 20. Okay, so since the 4 is right next to the absolute value, I know that is understood to be multiplication, just like if it was parentheses. Okay, and the absolute value of 20 is 20. So it's really 4 times 20. And you know that 4 times 20 is 80. Okay. Any questions about that? All right, evaluate the following exponential expressions. All right, so 4 to the power of 2, or in other words, 4 squared. So that means 4 times 4, and we know 4 times 4 equals 16. And then number 3 says negative 7 squared. So that's negative 7 times negative 7, which would equal positive 49, because a negative times a negative is a positive. All right. Number 4 is negative 3 cubed. So that's negative 2 cubed. So negative 2 times negative 2 times negative 2. So negative 2 times negative 2 would equal positive 4. So it's positive 4 multiplied by negative 2, which is going to equal negative 8. So whenever you have a negative number raised to an even exponent, your answer would be positive. And if you have a negative number raised to an odd exponent, it would be a negative answer. So we talked about even numbers would be like 2, 4, 6, 8, 10, and then everything else is odd numbers. So 3, 5, 7, 9 are odd numbers. Okay, but number 5, though, it's a little bit tricky. So it says negative 7 squared, but it doesn't have the parentheses around negative 7. So that means that the negative is not included in the base of the exponent. So the negative is separate. So it really means negative. It's like you could say negative parentheses 7 squared. So the negative is not squared, only the 7 is. So the negative is separate. So that gives you an answer of negative 49. All right, so with the parentheses around negative 7, that gives you positive 49, but without, it gives you negative 49. All right, so number 6 says negative 1 to the power of 4. So that's an even exponent, so I know that's going to make my answer be positive. So, and so I could write it out as -1 times -1 times -1 times -1. So you could say that you multiply a negative times a negative, that cancels out. And then again, you multiply a negative times a negative, and those cancel out. And you can see that's just going to be a +1. All right, using the order of operations. So we have 9 plus 7 times 2. So there's no parentheses or exponents, but we do need to multiply 7 times 2. So 7 times 2 equals 14. So then I have 9 plus 14. And 9 plus 14 is equal to 23. All right. So on number 8, so a lot of people get confused about parentheses. So when you think of PEMDAS and it says you need to do parentheses first, that means like if there is some operations on the inside of the parentheses that you need to actually do, then you would need to do that. But in this case, on inside these parentheses, there's no operations that you need to actually do. There's just a number. So that's not really what it's talking about when it says parentheses. All right, so there's nothing on the inside of any of the parentheses to actually do, but we do need to multiply is what we need to do right now. All right, so I'm going to look at that as -2 times -5 equals +10. All right, so then I have -6 plus 10. And that equals +4. Well, so the 2 is multiplied by the -5.
Oh, and then because.
Yeah, so it's -6 minus 2 times -5. So yeah, so the parentheses on the -6 really aren't doing any, they're really not serving any purpose except for, sometimes just people put parentheses around a number just only because it's negative and no other reason besides that. Jesus is joining us on Zoom. Hi, Zeus. All right. All right. Number 9. So in this case, this is where we have some things on the inside of the parentheses that we need to actually do. Okay, so let's see. So 1 minus 2 is going to equal -1. Right? So I have 2 different sets of parentheses that both have 1 minus 2. So they're both going to be -1. And, kind of partially because of the fact that they're negative, I'm going to go ahead and keep parentheses around those and bring the other stuff down. So it's like 4 times -1 squared minus 5 times -1 squared. Okay, so the next thing I want to do is exponents. So I did parentheses, now I'm going to do exponents. So -1 squared, meaning -1 times -1, that's going to equal +1. And the same thing right here, -1 squared, that's going to equal +1. And then I'll bring down the rest. So it's 4 times 1 minus 5 times 1. So the next thing I would do is multiply. So 4 times 1 is 4, and 5 times 1 is 5. So now I just am looking at 4 minus 5. And I know that 4 minus 5 equals negative 1. All right, number 10, let's see, there's nothing in the parentheses, but we do have exponents, so I'm going to do those. So 6 squared is 36. 6 times 6 is 36. All right, and 2 squared is 2 times 2 is 4. All right, I'm going to bring everything else down. So it's 36 minus 8 divided by 4 times 3 minus 1. All right, so next we want to do the multiplication and or division in order from left to right. So the next thing I want to do is divide 8 divided by 4. So 8 divided by 4 is 2. All right, I'm going to bring everything else down. So I have 36 minus 2 times 3 minus 1. All right, so next I have a multiplication that I need to do. 2 times 3 is 6, and then I'm going to bring everything else down. So that's 36 minus 6 minus 1. All right, so now I can just subtract straight across. So 36 minus 6 is 30, and then 30 minus 1 would equal 29. All right, number 11. 28 divided by 7 times 3. So the only operations are multiplication and division, so I'm just going to do them in order from left to right. So first I'm going to divide. 28 divided by 7 is equal to 4. And then 4 times 3 equals 12. Number 12, same kind of situation. It's only multiplication and division. So I'm going to go ahead and just do them from left to right. So 3 times 6 is 18. And then I just need to do 18 divided by 3, which is equal to 6. Let's see, number 13. So the first thing I need to do is multiply 3 times 2, which is 6. And then I'm just going to bring everything else down. So it's 15 minus 6 plus 2. All right, and now I'll just go, all I have left is add and subtract, so I'm just going to go straight across. So 15 minus 6 would be 9, and 9 plus 2 would equal 11. Okay, number 14. So no parentheses, but I do have exponents. So 4 squared, 4 times 4 is 16. And 5 squared, 5 times 5 is 25. Bring everything else down. So 16 minus 75 divided by 25 times 9 minus 9. All right, so next I'll do any multiplication and or division in order from left to right. Okay, so divide 75 divided by 25. Okay, so, I just think of like quarters, 75 cents, that'd be 3 quarters, right? So 75 divided by 25 is going to be 3. And then I'm just going to bring everything else down. Hey, Jesus, I can actually see his face with no mask on even. All right, 16. So that'll be 16 minus 3 times 9 minus 9. All right, and then I need to multiply. 3 times 9 is going to be 27. Bring the rest of it down. So I've got 16 minus 27 minus 9. All right, so now I can just go across. So 16 minus 27 is going to be negative negative 11. So and then negative 11 minus 9 would equal negative 20. All right. Number 15. So we do have some things that are on the inside of parentheses that we need to do. So 3 minus 6 is negative 3. And 3 minus 5 is negative 2. And then let me just bring everything else down. So and I want to keep it in parentheses for now. So that's negative 3 squared minus 9 times negative 2 cubed. All right, so now I got to do the exponents. So negative 3 squared, negative 3 times negative 3 would equal positive 9. And then negative 2 to the third power is going to equal negative 8. So I have 9 minus 9 times negative 8. So next I need to multiply. All right, so I can multiply, let's call that negative 9 times negative 8. So that's going to be positive 72. Oops. So I'm going to do 9 plus 72 equals 81. All right, number 16. All right, let's see. So let's start on the inside of the parentheses. And so I've got, inside the parentheses, I've got 2 cubed minus 5. So within that, I'm going to start with 2 cubed. So 2 to the third power, 2 times 2 times 2, is equal to 8. All right, and I'm just going to bring everything else down. All right, so I'm still including those parentheses, so that's going to be 8 minus 5 in parentheses. All right, here we go. All right, so now I still need to do the innermost set of parentheses. So the brackets are just like another set of parentheses. There's no different meaning for brackets. It's just, you know, they just wanted to kind of distinguish them from the parentheses, but basically it's the same thing. All right, so next I'm going to finish off this parentheses by doing 8 minus 5, which equals -3. Keep that in parentheses. And bring everything else down. Oh, sorry. Yeah, pause it. Oops. Bring everything else down. Okay, so now I need to focus on doing what's inside the brackets, because that's just like another set of parentheses. And within that, I need to multiply the 2 times 3. So 2 times 3 is 6. And again, just bring everything else down. All right. So I still need to do what's inside of the brackets, which will be 18 plus 6. So 18 plus 6 is equal to 24. Okay, so at this point, I don't think I need the brackets anymore because it would just be brackets around the number 24, which doesn't seem necessary. So it's just 24 divided by 42. Is that right? I think it is. Okay. So in that case, well, obviously 42 doesn't go into 24. So probably what we want to do is write that as a fraction and reduce it. So that's the same thing as saying 24 over 42. And then we need to reduce that. So I know that, so here's another place where we can use our divisibility rules. You know, what's the greatest common factor of those two? All right, so let's see, I know they're both even, so I could divide both of them by 2, but I could also divide by 3. I could also, can I divide, I can't think I can divide, I can't divide by 4. So I could divide by 3 or 6. Yes, I can divide by 6. So, yeah, yeah, I think so. All right, so if we divide both of these by 6, then that's going to be, so 24 divided by 6 is 4, and 42 divided by 6 is 7. So 4 over 7 is my final answer. All right, number 17. All right, so the fraction bar is a type of grouping symbol like parentheses. So with the fraction bar, it's, you know, the numerator, the top of the fraction, that's one group, and then the denominator, which is the bottom of the fraction, is another group. So you can just do like the top, and then do the bottom, and just do them separately, and then, you know, either divide them at the end or reduce the fraction at the end, whatever the case may be. So 18 plus 7 is equal to 25. So that's it for the numerator. And then in the denominator, though, let's see. So we need to do exponents. So 3 squared is 9, and 2 squared is 4. So that's 9 minus 4. All right. So 9 minus 4 equals -5. All right, so now we have 25 over -5, which is another way of saying 25 divided by -5. Yeah, so it's basically 25 divided by -5, it just equals -5. Oh, I don't know why I keep doing that. I'm like, yeah, your brain gets like obsessed with negatives at a point, I guess. Yeah, it happens. All right, so 25 divided by 5 is 5. Okay. All right. All right, number 18. Okay. So on the numerator, the first thing we need to do is divide. So 10 divided by -2 would be -5. So you have 37 plus -5 over, and we could go ahead and do that one as well, I think. 2 to the 3rd power, 2 times 2 times 2 is 8. And then 37 plus -5. So that's the same thing as saying 37 minus 5. So 37 minus 5 would equal 32. So now we just have 32 over 8, or in other words, 32 divided by 8, which equals 4. All right. All right. Number 19, so let's start with the parentheses. So 4 minus 6 is -2. I'm going to bring everything else down. -3 squared plus 3 times 12 divided by -2. So I need to finish doing what's on the inside of the brackets. So that means I'm going to do 12 divided by -2, which is equal to -6. And I can go ahead and keep that in brackets or parentheses, basically the same thing. All right, so next I'm going to do, now I'm done with what's inside my parentheses, so next I would do exponents. And so since there is no parentheses around that -3, we know that that negative is separate. So it's only the 3 that's getting squared. So it's -9 plus 3 times -6. No, yeah. No, it actually was negative this time. It wasn't just me. All right, so then 3 times -6 equals -18. So we have -9 plus -18. So that equals -27. All right, let's see here. So I guess we should start with the fraction, because again, that's like it's a grouping symbol, so it's like parentheses. All right, so we can go ahead and do 4 squared is 16, and 7 minus 3 is 4. All right, and I'm going to bring everything else down. So 32 divided by 16 over 4. And then minus a negative, I know I can change, I want to change that to a plus. So I'll just change that to +5. All right, so then I need to finish the fraction 16 over 4. This is the same thing as saying 16 divided by 4, which is 4. Okay. So 32 then divided by 4 plus 5. All right, so next I need to do dividing. So 32 divided by 4 is 8, and so it's 8 plus 5. And 8 plus 5 equals 13. All right, any questions about anything so far? All right. So next we are going to do a review of fractions. All right, and obviously we just talked a little bit about fractions, and hopefully you, I know you've learned things about fractions at some point in the past. All right. And hey, Jesus, you can see all the stuff I'm writing, right? Okay, good. Just making sure. Double checking. Okay. So in fraction notation, the top number is called the numerator. The bottom number is called the denominator. So 3 over 3, that's a number divided by itself, so that always equals 1. 3 over 1 would be 3 because a number divided by 1 is itself. 0 over 3 would be 0 because 0 divided by any number is 0. So this is basically the same thing we talked about when we talked about dividing like yesterday. And then 3 over 0, remember we said that 0 under is undefined. Same thing. All right. All right, so two fractions are said to be equivalent if they represent the same number. We simplify fractions by canceling or reducing fractions equivalent to 1. All right, so for example, 6 over 8, 6 is the same thing as 3 times 2, and 8 is the same thing as 4 times 2. So therefore, you could say that's the same as 3 over 4 times 2 over 2. 2 over 2 is 1, so therefore 3/4 times 1 is 3/4. All right. All right. For multiplying fractions, you basically just multiply straight across. You multiply the numerators together, multiply the denominators together. Okay, but at the same time, what I would usually do is reduce first, and then that makes it a whole lot easier. Okay, so see right here, okay, we did 16 over 15 multiplied by 5 over 4. So what this example is showing is actually multiply 16 times 5 equals 80 and 15 times 4 equals 60, and then find the least common denominator no, sorry, I said that wrong. The greatest common factor of both of those, which is 20, and reduce it. But you can make it a lot easier if you just reduce beforehand. So like I know that 4 goes into 16 4 times. And I know that 5 goes into 15 3 times. And then voila, that's basically it. 4 over 3. Okay, so it's a lot easier that way. All right, and then when you divide fractions, you flip the second fraction and then multiply. Okay, so that's, in other words, you multiply by the reciprocal of the divisor. So the reciprocal is when you take a fraction and you flip it over. So here is an example. They did 3/4 divided by 2/5. So they changed that to 3/4 times 5 over 2. And then just multiplied straight across. So in that case, there wasn't anything to reduce, so you multiply straight across and that's it. All right, and then for adding fractions, so if your fractions already have the same denominator, then, because before you can add or subtract fractions, they have to have a common denominator. And so once they have that common denominator, then when you add them together or subtract them, the denominator just stays the same and you just add or subtract across the top. So 1/5 plus 2/5 equals 3/5. All right, so that's easy peasy. So if you're trying to add fractions that do not have a common denominator, or same thing for subtracting, first you have to, well, one way of doing it is to find the LCD. Okay, so if you want to do 1/2 plus 1/3, you figure out the LCD, which is 6. And then you figure out, what do I have to multiply with 2 to equal 6? And the answer is 3. So that means you have to multiply the top and the bottom by 3. And what you have to multiply with 3 to get 6, which is 2, so you have to multiply the top and bottom by 2. So then it ends up as 3 over 6 plus 2 over 6 equals 5 over 6. All right. And then to change from an improper fraction to a mixed number, let's see. So they didn't put an example in here, but I'll just do an example then. All right, so let's say you have 9 over 7. So that's considered an improper fraction because the numerator is bigger, which, yeah, I don't really like the word improper because it implies there's something wrong with it. There's really not. There's really not anything wrong with it. It's just that sometimes, sometimes we use it like that. And actually, when I do things like college algebra, I always just leave my fractions as improper because that's easier. But for real life use and applications, it's probably easier to do a mixed number. So to change that to a mixed number, I would just say, basically you're dividing it. So 7 goes into 9 one time with 2 left over. And so there's the 2's left over the 7. So it's 1 and 2/7. All right, so that's how you change from an improper fraction to a mixed number. And then to go from, oh, I guess that's an example right there also. So 5 goes into 14 2 times with 4 left over, so 2 4/5. If you want to change from a mixed number to an improper fraction, you multiply. So 2 times 3 is 6. 6 plus 1 is 7. And then it's 7 over 2. All right. So if you want to multiply or divide mixed numbers, you would just change it into improper fractions first and then go from there. Okay. All right. Converting from fraction to decimal, you're just going to divide. Okay, and so we're not really using calculators at this time. So you could divide it out using long division, or you could do it using a calculator. I don't think we really need to go over that, but just know that you can change a fraction to a decimal just by dividing, but I don't think we're gonna be doing that right now. All right. Simplify 72 over 80. All right. So try to find the greatest common factor. Now, when you're simplifying a fraction, you don't necessarily have to find the greatest common factor, as long as you can find a common factor and divide it. And then, you'll figure out, you just kind of figure out from there, like if you need to reduce it more or if you're done, So for example, I could say, okay, well, I know I can divide both of these numbers by 2. So I'm not 100% sure if that's the greatest common factor or not, but it's, I don't really care. I'm just going to divide them both by 2. So if I do that, that's going to give me 36 over 40. Well, looking at that, I can see that I could definitely reduce that again. I could reduce that by 2, but at this point, it's kind of obvious to me that I could also reduce that by 4. So that's what I'm going to do. So I'm going to divide both of those by 4. So 36 divided by 4 is 9, and 40 divided by 4 is 10. So 9 over 10, and those don't have any common factors. So now it's reduced. It's simplified. All right. All right, so multiplying fractions. Well, first of all, I see that I have a negative times a negative. So I know those negatives are going to cancel each other out and make my answer a positive. And now let's see what I could reduce. So 8 and 12 could be reduced by 4. So 4 goes into 8 2 times, and 4 goes into 12 3 times. Okay, so then I can just do 3 times 3 is 9, and 2 times 5 is 10. So that makes it a lot easier, in my opinion, if you go ahead and reduce it first and then multiply. All right, number 3 is a negative divided by a negative, so those will cancel out. All right, so when you divide, you have to flip the second fraction and multiply. So this is going to be 3/4 multiplied by 8 over 5. All right, so that's the first thing we have to do. Next, I'll check to see what I could reduce. I know 4 goes into 8 2 times. So 3 times 2 is 6. And then on the bottom, you could say that's a 1, and 1 times 5 is 5. So 6 over 5. All right, now that is an improper fraction. And, personally, I'm quite comfortable with improper fractions, but I'm not sure, you have to pay attention when you're doing your homework, what the instructions say. Because, that is considered a simplified fraction, but if it says that you need to enter your answer as, possibly a mixed number, then we could do that. So 5 goes into 6 one time with 1 left over. So it's 1 1/5. So either one of those answers is acceptable. So number 4, I've got two mixed numbers that I'm supposed to multiply together. So the first thing I want to do is change those into improper fractions. So 2 times 1 is 2, plus 1 is 3, so that's 3/2. And then 4 times 3 is 12, 12 plus 3 is 15, so that's 15/4. All right, and let's see. There's nothing I can reduce, so just multiply straight across. 3 times 15 is 45, and 2 times 4 is 8. Again, that can't be reduced, but it could be. It is an improper fraction, so if necessary, I can change it into a mixed number. So 8 would go into 45 5 times with 5 left over. So either 45/8, or that's the same thing as 5 5/8. All right, write the fraction as a decimal. Okay, so I guess we do have to do that. All right, so since we're not using a calculator, we'll have to use long division. However, I can see that this fraction can be reduced, so that'll probably make it easier if I go ahead and reduce it first. All right, so let's see. So 2 can go into 14 7 times, and 2 can go into 16 8 times, so 7/8. All right, so then I'll go ahead and divide. So that's 7 divided by 8. So 8 going into 7. All right, well, of course, 8 doesn't go into 7. So what we do, we put a decimal point after the 7. And I'll go ahead and put a 0 above the 7. And then I'm going to put a 0 after the 7. So now I'm asking myself, how many times can 8 go into 70? So 8 times, because 8 times 8 is 64. 70 minus 64 is 6. All right, so then let me put another 0 there that I can bring down. So 8 goes into 60. How many times? 7. 7 times 8 is 56. 60 minus 56 is 4. So do another 0 and bring it down. And then 8 goes into 40 exactly 5 times. So that is equal to 0.875 as a decimal form. All right, and then number 6, same thing. All right, so that can't be reduced, so I'm just going to go ahead and divide it. So 11 into 5. All right, well, how many times can 11 go into 50? 4 times. 4 times 11 is 44. 50 minus 44 would be 6. Let's do another 0. 11 goes into 60 5 times. 5 times 11 is 55. 60 minus 55 is 5. And so let's do another 0. So 11 goes into 50 4 times. And we are going around and around. Okay, so we're just going to keep on repeating 4 5 4 5 4 5. So 0. So what we'll do is write 0.45, and we put a line over 4 5 to show that the 4 5 is repeating. All right, multiplying 5 over 7 times 1 over 11. There's nothing to reduce, so just multiply straight across. So that's 5 over 77. Number 8, 7 over 3 divided by 3 over 2. Well, first we need to flip because it's dividing. So we need to flip it. 7 over 3 multiplied by 2 over 3. So yeah, since it's dividing, we have to do that first, then see if we can reduce anything. And now we can't. So 7 times 2 is 14, 3 times 3 is 9. Okay, so if we wanted to change that to a mixed number, 9 goes into 14 one time with 5 left over, so 1 and 5 9. So it could be either of those answers, just depending on the instructions. So 5 over 2 divided by 2. Okay, well, 2 is the same thing as 2 over 1, and it is dividing, so we need to flip the second fraction and multiply. So 5 over 2 multiplied by 1 over 2. And there's nothing to reduce, so multiply straight across, and that equals 5 over 4, which is also the same thing as 1 and 1/4. Seven over 0, 0 under is undefined. Okay, subtracting. All right, so you would first want to figure out the least common denominator. So the least common denominator between 3 and 6 is 6. So we can rewrite the problem using denominator of 6. So what do we have to multiply with 3 to equal 6? 2. So that means we also have to multiply that numerator by 2. So 2 times 2 is 4. So, and then the second fraction, we can just leave it the same because it already has the LCD there. So 4 over 6 minus 1 over 6 equals 5 over 6. And then on number 7, it already has the LCD of 20, so that's just going to stay the same. And 7 minus 5 is equal to 2. I almost said negative 2. Okay, but I did. All right, and then we can reduce that because 2 can go into 2 one time and 2 can go into 20 10 times. So 1 over 10. All right, number 13. So what would be the LCD? $24. So what do you have to multiply with 2 to get 24? 12. So then you also have to multiply that numerator times 12. That gives you 12 over 24 plus 3 over 24. All right, so the 24 is going to stay the same. And then 12 plus 3 is equal to 15. And we can reduce that by 3's because 3 goes into 15 5 times, 3 goes into 24 8 times. So 5/8. All right. And then number 14, we need to, I'm going to change those into improper fractions. So that would be 3 times 10 is 30 plus 1, so that's 31 over 3.
And then 41.
Yep. So that'd be 36, 41 over 6. So minus 41 over 6. So your LCD is 6. So multiply that by 2. So that'll be 62 over 6 minus 41 over 6. All right. So 32 minus 41 is 21. So 21 over 6. We can actually reduce that by 3s. 3 goes into 21 7 times. 3 goes into 6 2 times. So 7 over 2. So if they tell you that, you know, improper fraction is an acceptable answer, then we can leave it like that. Or if we wanted to change it to a mixed number, 2 goes into 7 3 times with 1 left over, so it's 3.5. And we're done. I didn't even go all the way to 145 today. Y'all have any questions about anything? Make sure you get on My Labs Plus if you haven't. It seems like I have a thought process that Monday and Wednesday will be the long classes and Tuesday and Thursday will be the short classes. Sound okay? Is that okay with y'all? All right. See y'all later.